if I'm going to take a look and figure out which one, either it's going to be linear, y equals x to the 1, or quadratic, which I think it probably is because it's talking about a baseball being hit in the air. It could even be some y equals x cubed. It could be some y equals x to the 4th. It could be linear, quadratic, cubic, or quartic. Okay? One way to find out is to look at the differences in the y's. And when I get the differences in the y's to be all the same, it will tell me which one it probably should be, okay? So let's first of all slide this up, and let's get our first differences. So I'm just going to subtract each value. These are my y values from up above. These are my y values, okay? And I'm going to go ahead and try and find my first differences, okay? So getting my calculator, I'm just going to go ahead and subtract 397 minus 365. I get an answer of 32. I'm going to go 365 minus 334. I get an answer of 31. 334 minus 304, and I get 30. Probably 29. Probably 28. Probably 27. And I can double check. I can't once I start recording, I'm sorry. So when I did my differences, I got 32, 31, 30, 29, 28, 27, 26. Okay, so that's my first. That's my first differences. So it's not a y equals some x to the 1. Okay, it's not. It's not. So if I look at its graph, they actually did a graph for me. It almost looks like it could be a linear, right? Just about looks like this is a straight line, but it's not a straight line because our first differences didn't work, right? So it could be a very gradual curve. So let's do our second difference. Well, that's easy. 1, 1, 1, 1, 1, 1. If I subtract 32 from 31, boys, stop talking, please. So then my second differences work. If you get them to be all the same, then you've found exactly which one of these it should be. So it needs to be some y equals x squared, okay? So if that's the case, it says use the graphing calculator to draw a scatter plot. Well, they've done that to us, but we're going to actually use the regression, and we're going to use the quadratic regression. So how do we do that? We're going to use our stat button again. Okay. We're going to let this go back to our data. This will be my L1 and my L2, right? We've done this before, so I'm going to go. Have you done this with us? I don't think you have. I'll go slowly. Do you have a calculator? Here, you can use mine. I'll grab a different one, okay? So let's go to stat. Bruce, I'm going to help you get it, okay? So I'm going to go slowly so you can see this. And I am recording this if you're going to watch again, okay? So we go to stat. Edit. It's on edit. Push enter. I'm going to clear my list. So I'm going to go and highlight list 1, clear, down arrow, clear. Highlight list 2, right? Clear, down arrow. So my lists are cleared. Okay. Now I'm just going to put in my x values for list 1. 80, 85, 90, 95, 100, 105, 110, and 115. Okay? That's my list 1. I'm going to move over, and I'm going to go list 2, and I'll put in my y data. 194, 220, 247, 275, 305, whoops, 304, yeah, 304, 334, 365, 397, okay? Tell me when you're ready. So now I want to calculate an answer, right? So I'm going to go to stat again, go over to calculate, and I want to calculate I know which one I'm going to do. I'm going to do the quadratic, right? We know it's the quadratic because my second differences became the same. So I'm going to go to my quadratic regression, enter. I'm going to go down to calculate, enter, and here's my answer. So my answer is a y equals a 0.02x squared plus 1.9x minus 86. Okay? Now, we can also check to see how good it is, because remember we had that diagnosis. We could find the R value. Anybody have the R value on their calculator?
Yeah, I do.
Did you get 1? R squared equals 1?
I did.
So if you don't have it, you can go into the catalog. Did you get an R squared on yours? Did you get an R squared?
Why does yours not have it?
I need to turn it on. Whoever used my calculator last just didn't turn it on. So I'm going to go to my catalog. I'll show it to you real quick. I'm going to go to diagnosis, diagnostics. Diagnostics, I'm going to turn my diagnostics on. And then, Cooper, when I do it again, right,
Yeah.
I'll have it. And of course, an R squared of 1 tells me 100% of my data fits this graph. So we know it's good, right? Okay, now turn the page. Turn the page. So here's my equation. I had a y equals a 0.02x squared plus a 1.9x minus 86, right? Well, now we can use our formula to actually answer a question. Here we're told that we got an initial speed of 120. What's the distance? Let's just plug 120 in for x, right? So all we're going to do is use our equation to find how far the value or distance at 120 miles. So I'm going to go y equals 0.02 times 120 squared plus a 1.9 times 120 minus 86. Okay, so then I'm just going to use my calculator, right? My calculator do the work for me. 0.02 times 120 squared plus 1.9 times 120 minus 86, and I get an answer of about 430 feet, okay? So far, so good? I'll wait for you. I just used my equation. I just plugged 120 in for x, got the answer, okay? Okay, tell me when you're ready, Brian, and then we're going to actually go all the way to page, I believe, 105, okay? I'm going to go to page 105, and I want to do number 10, okay? All right, so here's a real-life problem, and sometimes data doesn't work out perfectly when you're using real data, but let's do the same thing. So what we have is the MVP football player, where X represents the number of years, and find a polynomial model, which is data for the first 5 years. Use the model to estimate the year that the autograph will be valued at 5 million, okay? So let's check it out. So first of all, let's take a look at our first differences, okay? So to do my first differences, I'm going to subtract these values, subtract my y values, right? So the first difference is I'm just going to use my calculator. I'm going to go 1,246 minus 510. I get an answer of 736. 510 subtract 162. I get a 348. 510 subtract, nope, I already did that one. 162 subtract 34, I get 128, and 34 minus 6, I get a 28. Okay, so the first differences didn't work at all, did it? Right? So it's not linear. Okay, let's try these and do our second differences, right? So let's do our second differences. So I'm going to subtract these values. Okay, so clear. 736 minus 348, and an answer about 388. 348 subtract 128, and I get an answer of about 220. And 128 subtract 28, and I get an answer of about 100, okay? So it's not a x squared, it's not an x, it might be a cubed, yes.
Do you go backwards when you're subtracting and you go forwards? Like
You can subtract either direction. I just subtracted this way, Nikolai, because I didn't want negatives, right?
Alright.
Right, does that make sense? You can go either direction as long as you're just consistent, Nikolai, does that make sense?
Yes.
Don't change direction halfway through subtracting. That would be bad. Okay, let's try third. Okay, I don't know, so third. I'm going to go 380 minus 220. I get 160. I get 220 minus 100, and I get 120. So they're pretty close there, and we don't really have another choice because we're out of numbers, right? So those are pretty darn close. With real data, you won't get them to be exact. Does that make sense? Because it's not going to be they're not going to be perfectly lined up. So I'm going to go along with those. Those numbers are close enough. So I'm going to go y cubed. Okay, now, well, let's figure out what it is. What is the equation? So go back to my stat, right? And I'll probably do the work on my calculator. So I'm going to go to stat, edit. I'm going to clear list 1, clear list 2. I'm going to put in my x values into list 1. 1, 2, 3, 4, 5. And I'll put my value in list 2, 6, 34, 162, 510, 1,246, right? I think it's a cubic. I'm going to try it. I'm going to go, all right, I'm going to go to stat, calculate my cubic, right? I calculate that. And now with my r squared, that's a pretty darn good r squared. So, Verusius, if it's 1, you know 100% of the data fits. 0.99999, that's good. So I'm going to say it's cubic, okay? So here's my answer for this equation. It's got to be a y equals a 24x cubed minus a 99.1x squared plus 160.9x minus 80.4. Okay, that's going to be the equation I use, where x represents years and y represents the value. Okay, now, these are in terms of thousands of dollars, right? So, if we want to find out when this is worth 500,000,
What? It says 5 million.
5 million, right? Yeah,
Oh wait, but you changed it.
from thousands, right?
Okay.
Right. So I'm going to try and do this. You're going to set it equal to 5,000,000. You okay with me? 5,000,000 is 5 million. Cooper, here's where it goofs us up, is this darn thing here in thousands of dollars, right?
Okay.
So this number, 5,000 is 5,000,000, 5,000,000 is 5 million, okay? Is equal to 24x cubed minus 99.1x squared plus 160.9x minus 80.4. How do you solve for x when it's like that? How do you solve for x? What? Well, you graph it. You graph it. So, I'm going to go to my graph. Okay, I'm going to go to my y equals, okay? Clear that. And I'm going to put in my 24x to the third power minus 99.1x squared plus 160.9x minus 80.4. Now, before I graph this, I've got to be smart enough to use the right window, okay? Now, the window I'm going to use is going to be a window that's going to comply with my data, okay? So I'm going to go to my window before I graph it, and I'm going to go from 0 to probably, how about 10 years, okay? My y minimum 0, 2. I need to at least get up to 5,000, so let's put it to 6,000. Whoops, that's my minimum. 0, oops, clear. 0 to 6,000. Graph it. Okay, here's my graph. Here's my graph. And I'm going to trace it until the y value gives me 5,000, okay? So I'm going to go to trace. And I'm going to trace it until I get to 5,000. So I'm about 7 years. Okay, see that? It's a little over 7 years, maybe about 7.5 years. So I'm going to say about 7.5 years. Okay? Whew! Was that a hard lesson or an easy lesson?